third orbit, that is in the valence orbit, that is in the outermost orbit. These two electrons are the valence electron. This magnesium metal can donate these two electrons. So if we donate two electrons, it will get two positive charge, so that it is written as Mg2 plus. In the case of sulfate, it is written as 2 minus. Why? The atomic number of one oxygen atom is 8. The maximum number of electrons revolving in the first orbit of oxygen atom is 2. Even though the maximum number of 8 electrons can revolve in the second orbit, we are having only 6 electrons as remaining, so that we can place only 6 electrons in the second orbit in the case of the oxygen atom. So the valence electrons are 6. It is the non-metal. It will receive the electrons, that is, it will accept the electrons from the metal. The metal magnesium is ready to donate 2 electrons. One oxygen atom requires 2 electrons in order to get the octet structure, that is the nearest noble gas configuration structure, that is the stable structure. Here there are 4 oxygen atoms, so 4 oxygen atoms require 8 electrons. The sulfur, the atomic number of the sulfur is 16. In the case of sulfur, in the first orbit, there are 2 electrons. In the second orbit, the maximum number of electrons revolving is 8. So the remaining 6 electrons are placed in the third orbit, that is in the valence orbit, that is in the outermost orbit. This one sulfur atom gives 6 electrons to the 4 oxygen atoms. These 2 electrons is given by the magnesium metal. Magnesium metal is ready to donate 2 electrons. The sulfate requires 2 electrons. That is, it is ready to accept 2 electrons, so that if it accepts 2 electrons, it will become as -2. So that we are writing as sulfate 2 minus. On seeing the table, we can understand that the limiting molar conductivity of magnesium is 106 Siemens centimeter square per mole. We can also understand that the limiting molar conductivity of sulfate 2 minus is 160 Siemens centimeter square per mole. If we add 106 and 160, we will get 266 Siemens centimeter square per mole. This is the limiting molar conductivity of the given electrolyte magnesium sulfate. My dear students, in this video we have learned that how can we find the limiting molar conductivity of an electrolyte. If this video is most beneficial to you, you can share this video with your friends and classmates. You can also subscribe my channel. My dear students and parents, in this video we are going to suggest a way to determine the limiting molar conductivity value of water. In the chapter electrochemistry, in the subject chemistry to the +2 CBSE students, you can see this fact on the board. By God's grace, my educational videos are available to 10th CBSE, plus 1 CBSE, plus 2 CBSE, NEET and IIT students in the subjects mathematics, physics, chemistry, zoology and botany in English language. Here the question is, suggest a way to determine the limiting molar conductivity value of water. In this question, they are not asking to find the limiting molar conductivity value of water. They are simply asking to suggest a way to determine the limiting molar conductivity of water. We know that water is a weak electrolyte. What is electrolyte? Electrolyte is a substance. When this substance is dissolved in water, it breaks into, that is, it dissociates into its constituent ions, that is cations and anions. What is strong electrolyte? Strong electrolyte is a solution or solute. This solution or solute completely or almost completely ionizes or dissociates into its constituent cations and anions. What is weak electrolyte? Weak electrolyte is also a solution or solute. In this case, the solution or solute does not completely ionize, does not completely dissociate into its constituent ions, that is cations and anions. That is, in the case of weak electrolyte, the solution or solute partially dissociates, partially ionizes into its constituent ions. We have to find the limiting molar conductivity of water applying the Kohlrausch law of independent migration of ions. Why should we select the Kohlrausch law of independent migration of ions in order to determine the limiting molar conductivity of a weak electrolyte? We know that weak electrolytes such as acetic acid have lower degree of dissociation at higher concentration. Note the word, at the higher concentration. When we add more and more water in the weak electrolyte, that is at infinite dilution, the concentration of the electrolytic solution becomes zero. When the concentration becomes zero, the electrolyte dissociates completely. That is the degree of dissociation equal to 1. Note the point. We already told that the weak electrolytes have the lower degree of dissociation at higher concentration. Here we have made the concentration to 0. So at this lower concentration, the electrolyte dissociates completely. In this lower concentration, the conductivity of the solution becomes very low. So, the conductivity of the solution cannot be measured accurately in this low concentration. For that reason, we are following the Kohlrausch law of independent migration of ions. In the question, no other information is given other than the statement that suggests a way to determine the limiting molar conductivity of the water. So, we have to think, how can we get the water? We are well aware that When the acid combines with the base, we will get salt and water. So, let us take an acid, that is hydrochloric acid, HCl. HCl is a gas. When it is dissolved in water, it becomes the acid, that is hydrochloric acid. It is going to combine with the base sodium hydroxide. So the acid combines with the base, that is sodium hydroxide, to form the salt. Which salt? The sodium chloride salt and water. See the equation. HCl is the acid, sodium hydroxide is base, sodium chloride is salt, H2O is water. So from this equation we can get the equation for the water, that is H2O. Then what is the equation for water? If we bring sodium chloride from left side to right side, it will become as minus sodium chloride, that is NaCl. What is the Kohlrausch law of independent migration of ions? The law states that the limiting molar conductivity, that is lambda m naught of an electrolyte, can be represented as the sum of the limiting molar conductivity of the cations and the limiting molar conductivity of the anions of that electrolyte. It means that if we add the limiting molar conductivity, that is lambda m naught of the cations, and the limiting molar conductivity, that is lambda m naught of the anions, we will get the limiting molar conductivity of the electrolyte. So we can write this equation applying the Kohlrausch law of independent migration of ions, that is limiting molar conductivity of water equal to limiting molar conductivity of HCl plus limiting molar conductivity of sodium hydroxide minus the limiting molar conductivity of sodium chloride. This is the way to determine the limiting molar conductivity value of water. It is not asked to determine the limiting molar conductivity value of water, but we can easily find the limiting molar conductivity of the water applying the Kohlrausch law of independent migration of ions. How can we determine? That is limiting molar conductivity of H2O equal to the limiting molar conductivity of HCl can be written as limiting molar conductivity of H plus limiting molar conductivity of Cl minus. Similarly, the limiting molar conductivity of sodium hydroxide, that is base, can be written as limiting molar conductivity of Na plus limiting molar conductivity of OH minus. Likewise, we can also write the limiting molar conductivity of sodium chloride as limiting molar conductivity of Na plus limiting molar conductivity of Cl minus. The Kohlrausch examined limiting molar conductivity for a number of strong electrolytes. We can get the information for the limiting molar conductivity of the cations and the anions from the table given. If you see the table, you can understand that what are the limiting molar conductivity value of cations and the anions. My dear students, if this video is most beneficial to you, you can share this video with your friends and classmates. You can also subscribe my channel. If you want to get all information contained in this chapter, I appeal to the students to see all my videos. My dear students and parents, in this video we are going to study why the conductivity of a solution decreases on dilution in the chapter electrochemistry in the subject chemistry to the +2 CBSE students. By God's grace, my educational videos are available in YouTube to 10th CBSE, +1 CBSE, +2 CBSE, NEET and IIT students in the subjects mathematics, physics, chemistry, zoology and botany in English language. It is the in-text question 3.7. What is the question? Why does the conductivity of a solution decreases with dilution? Before going to the answer, I want to say some information. You know that there are two types of conductance. One is the metallic conductance. The other name for the metallic conductance is electronic conductance. In this metallic conductance, the current is conducted by the electrons, that is by the free electrons, that is by the loosely bound electrons. Another type of conductance is ionic conductance or electrolytic conductance. In this case, the current is conducted by the ions produced in the solution, in the electrolytic solution. What is conductance? Conductance is the inverse of the resistance. What is the unit of the resistance? The unit of the resistance is ohm. Therefore, the unit of the conductance is mho or Siemens. The conductance is denoted by the letter capital G. The resistance is denoted by the letter capital R. Then we are coming to the expression conductivity. What is the conductivity of a solution? The conductivity of a solution is also the conductance of the solution. So therefore, what is the difference between conductance and the conductivity is, in the case of conductivity, the solution taken should be 1 unit volume. The 2 platinum electrodes taken should have the cross-sectional area of 1 unit. Moreover, the distance between these 2 electrodes be unit length. That is 1 unit length. Conductivity of a solution at a given concentration is the conductance of 1 unit volume of solution kept between 2 platinum electrodes with unit cross sectional area and at a distance of unit length. What is the SI unit of conductivity? The SI unit of conductivity is Siemens per meter. It is also called mho per meter, Siemens per meter or mho per meter. That is the unit of conductivity can also be expressed in Siemens per centimeter. By which letter the conductivity is denoted? The conductivity of the solution is denoted by the letter kappa, that is by the letter K. At this place, it is also useful to say about the molar conductivity of the solution. Here also the conductance of the solution. Here instead of 1 unit volume of solution, 1 mole of solution is taken. The volume of 1 mole of electrolyte solution is taken. Here also the cross-sectional area of the electrodes should be unit area. The distance between the electrodes in this case also unit length. So the difference between the conductivity and the molar conductivity is, in the conductivity we are taking unit volume of the solution. In the molar conductivity we are taking the volume of 1 mole of the solution. That is the difference between the conductivity and the molar conductivity. The students should note the difference between the conductance, conductivity and molar conductivity. Then do you know what is the SI unit of molar conductivity? The SI unit of molar conductivity is Siemens meter square per mole or Siemens centimeter square per mole. In the case of the solution, the conductivity depends on the number of ions produced by the solution. How many ions are present in the solution is important to determine the conductivity of the solution. If the number of ions produced by the solution is greater, then the conductivity will also be greater. It means that the conductivity of the solution is directly proportional to the number of ions produced by the solution. Suppose we are taking 1 volume of salt solution. It means that we are dissolving some amount of salt, that is common salt, that is sodium chloride. The volume of the solution initially is 1 liter. In order to determine the conductivity of a solution, we need unit volume of the solution. In this case, 1 liter of the solution. But after adding 1 more liter of water, the volume of the solution is now as 2 liter. We are adding only the water. By adding the water, the solution has become diluted. What is the meaning of dilution? The meaning of dilution is, if a solution is diluted, its concentration will decrease. Suppose the number of ions taken in 1 liter solution is 1200. Now we are adding only 1 liter of water. We are not increasing or decreasing the number of ions produced by the solution. That is produced by this 2 liter solution. Number of ions remains as it is, that is 1200. Therefore, 2 liter volume of solution, the number of ions produced is 1200. But we don't need the number of ions produced by the 2 liter volume of the solution. In order to determine the conductivity, we need the number of ions produced by 1 liter volume of the solution. So that to 2 liter solution, the number of ions is 1200. Therefore, to 1 liter of the solution, if we calculate, we will get 1200 by 2, that is 600. It is the ions produced per unit volume of this salt solution. So here, when we dilute the solution, the number of ions decreases. The number of ions is responsible to carry the current. Then when the number of ions are reduced, what will happen? The conductance of the current will decrease, so that the conductivity of the solution decreases on dilution. As per the IUPAC recommendation, the term conductivity is used instead of specific conductance. My dear students, in this video we have learned that when the solution is diluted, that is when the concentration of the solution decreases, the conductivity of the solution, that is the current conductivity of the solution, decreases. If the students want to know all the informations contained in this chapter electrochemistry, I appeal to the students to see all my videos uploaded in the YouTube relating to this chapter. If this video is most beneficial to you, you can share this video with your friends and classmates. You can also subscribe my channel. My dear students and parents, in this video we are going to study how to calculate the conductivity and molar conductivity of a solution, that is electrolytic solution. By God's grace, my educational videos are available in YouTube to the 10th CBSE, plus 1 CBSE, plus 2 CBSE, NEET and IIT students in the subjects mathematics, physics, chemistry, zoology and botany in English language. The sum is the resistance of a conductivity cell filled with 0.1 mole per liter potassium chloride, that is KCl solution, is 100 ohms. If the resistance of the same cell when filled with 0.02 mole per liter potassium chloride solution is 520 ohms, calculate the conductivity and molar conductivity of 0.02 mole per liter potassium chloride solution. The conductivity of 0.1 mole per liter potassium chloride solution is given. In the sum, the solution, that is the electrolytic solution, given is potassium chloride, that is KCl. This solution, that is electrolytic solution, potassium chloride, is given in 2 concentrations. Now let us see what is the concentration given in the first case, and what is the resistance given in the first case, and what is the conductivity of the solution given in the first case. That is, in the first case, the concentration is 0.1 mole per liter. At this concentration, the resistance of the cell is 100 ohms. At this concentration, the conductivity, that is K, that is kappa, at this concentration is 1.29 Siemens per meter. So in the case of 0.1 mole per liter concentration of potassium chloride, 3 data have been given.